Hello, my name is James Brown, and today I'll be demonstrating the Windows PowerShell foreach loop. The keyword foreach is used in Windows PowerShell to iterate through a series or list of items with the intent of performing operations using each item. Usually, the objects being iterated through with the foreach loop is an array or a collection of objects. When we want to perform some action on each item in the array, we use the foreach keyword to step through the array one unit at a time and act on the object. In the following example, we will create an array of the numbers 1 through 10 and store it in a variable called $numbers. If we call the variable, we will get a list of the numbers 1 through 10, one per line. Now suppose we want to square each number, multiplying the number by itself. We can't simply square the $number variable itself. Instead, we're going to use foreach to iterate through each unit in the array, then multiply the number by itself. The syntax is for each $number in $numbers, or each unit in the array, then perform the following. Write to the screen, the square of $number is $number times $number. Running these commands, we can get the square values of each number in the array. And as we can see, we have the square of 1 is 1, the square of 2 is 4, and so on. We can also use the foreach loop to iterate through a list of files and perform any number of actions on each one. In the following example, we will use the set location commandlet to change directories to the C Windows System 32 folder. Then we'll use the get child item commandlet to find all the files contained in the working directory that have the $.txt extension. Looping through all of those, we'll then write them to the screen. Running these commands, we can see that there are 3 files in the current folder with a txt extension, and now we can perform all sorts of operations on these files, such as copy them, edit them, or even delete them. Occasionally, when looping through a list or array, we may want to stop performing the actions midway through, usually based upon some special criteria. In such a case, we can use the break statement to exit the current script block, and the rest of the loop will not be executed. In the following example, we will reuse the $numbers variable, which contains the integers 1 through 10. Then we'll use the foreach keyword to loop through the array of numbers. First, we'll evaluate if the number is not equal to 7. If it is, then we continue and print the unit to the screen. However, when we do reach the number 7, we'll use the break statement to terminate the loop. Now we'll run the commands, and as we can see, each number is printed as expected until the 7 has reached its turn in the loop. The break statement terminates the loop, preventing the remaining integers in the array from being evaluated. A similar concept to the foreach keyword is the for statement, which allows us to create a loop that will run our desired commands for a certain number of times, but without needing to create an array beforehand. In the for statement, we create a starting unit, a condition, and an increment to iterate through the loop. In this example, we begin by setting the variable $i equal to 1. Next, we evaluate if the variable is less than or -lt the number 5. If it is, then the commands within the script block are executed. And finally, we use $i++ to increment the variable by 1 and repeat the process. This will continue until $i is equal to 5, at which point the variable I will no longer be less than 5, and the loop exits. To perform this logic in a separate commands would be more work and prone to error. Using the for loop is a handy shortcut. And we run the commands. Here we can see the loop cycle through the numbers 1 through 4, printing them to the screen, and when the variable reached 5, the evaluation failed, since 5 is not less than 5, and so the loop ended. We're not restricted to the above values when using the for statement. We can use any valid variable name instead of $i, such as $counter or $turns. We can also make the initial variable equal to any number that makes sense, such as 0, 2, or 10 billion. Nor do we have to increment our counter by 1. In the following example, we'll begin with unit being equal to the number 6. We'll increase the variable by 9 in each iteration, and we'll stop when the variable is less than or equal to -LE 100. When running the commands, we can see that the loop begins with 6, increases by 9 each time, and ends when it is no longer less than or equal to 100. Likewise, we can decrease the increment if that makes more sense. In this example, we're going to count down from 5 to simulate a rocket liftoff. We'll begin with count equal to 5, count minus minus to decrease the count by 1, and we'll continue the loop until count is no longer greater than -1. And now we'll run the commands, and we'll see it counting down, liftoff. Another looping concept common to both programming in general and PowerShell in particular is called while. In this concept, the loop is continued indefinitely for as long as a particular condition is met. The loop could occur one time, many times, an infinite number of times, or even no times at all. The while loop has simpler syntax than the for statement, and it's best used when the number of desired loops is unknown. Syntax is simply while a condition exists, run the code block. Unlike the for statement that usually requires the number of iterations to perform, like the digits in an array or the rows in a text file, the while loop will perform actions until a certain condition is no longer true, no matter how long that might be. In the following example, we'll assume we need to know exactly when the top of the minute has occurred, meaning the point in time when the current second count is exactly 0. First, we'll set the variable $current second equal to false, which will reset the variable every time we run the script. Next, we'll add the while loop. As you can see, the code block runs the commandlet getDate and extracts just the value of the current second, storing it in the variable $current second. Then the start sleep commandlet will pause the script for 1 second. A star will be written to the screen to serve as a visual counter, and the loop begins again. If current second is not equal to 59, then the code block is run again. This will repeat until current second finally is equal to 59, whereupon the loop is exited, and PowerShell will inform us that the computer's time is at the top of the minute. And now we can run the code and see how it works. And there we are. When we run this code, we don't know how many times it will loop, whether it be 1 second's worth or nearly a minute's worth. If all we are concerned about is when it's exactly the top of the minute, then we can let the while loop keep track of that. This sort of code block would be difficult to construct with just a for statement or a for each loop, because it would be impossible to know how many times the code block needs to loop until we've reached the top of the minute. The use of for and for each loops is a key concept in both scripting and programming. Once again, I'm James Brown, and thanks for watching.